Hello everyone, welcome to another video. In this video, what we're going to focus on is multiplication of matrix. Now, we multiply matrix by multiplying the row by columns, right? And we also multiply the corresponding elements. You must also bear in mind that two matrices can be multiplied only if there are as many columns in the first matrix as there are rows in the second matrix. The resultant matrix will have the same number of rows as the first matrix and the same number of columns as the second matrix. Example, let's say that you are given a 2 by 3 matrix to multiply with a 3 by 5 matrix. Then your resultant matrix is going to be a 2 by 5 matrix, right? And the same is true if you are given a 3 by 2 matrix to be multiplied by a 2 by 1 matrix. Then the resulting matrix should be a 3 by 1 matrix. And it is also true that if you are given a 2 by 2 matrix to be multiplied by another 2 by 2 matrix, the resulting matrix will be a 2 by 2 matrix, right? So here we have matrix A, which is defined as 2, 4, -1, 5, and matrix B is defined by 1, 3, 6, and 2. Now, clearly we can see that matrix A has 2 rows, right? So 2, 4 would be row 1, and -1, 5 would be row 2. So this is an example of a 2 by 2 matrix. It has 2 rows and 2 columns. Now, for matrix B, row 1 would be 1, 3, and row 2 would be 6, 3. So it has 2 rows, right? And it also have 2 columns. Column 1 would be 1, 6. And column 2 would be 3, 2. So this is a 2 by 2 matrix. Now, in order to determine if these two matrices can be multiplied, the number of columns in the first matrix, which is this 2 here, must be equal to the number of rows in the second matrix. So if we highlight that, we can see that here the number of columns is 2. And the number of rows in the second matrix here is also 2. So because the number of columns is equal to the number of rows, therefore these two matrices can be multiplied. Now after multiplying these two matrices, the resultant is going to be a 2 by 2 matrix. As you can see, the number of rows in the first matrix is the same as the number of columns in the second matrix, right? So let's go ahead now and find AB. So we're going to determine A, B. And AB here means A times B. Now, it is the row times column. That's how we multiply matrix. So it's going to be, let's divide this up into row here. Draw a line here, you can see row 1, row 2, and let's divide this up into columns. So let's divide this here, and you can see column 1, column 2, right? So we can put C1 for column 1, and we can put C2 for column 2, and here we can put R1 for row 1, and we can put are 2 here for row 2. Now we multiply corresponding elements. So matrix A times B is going to equal to, if we are multiplying the corresponding elements, we are going to take this 2 to multiply this 1. It's going to be 2 times 1 plus, now we're going to multiply 4, which is the second element, times the second element here. So it's going to be 4 times 6. It's going to be 4 times 6. Now we're going to multiply row 1 by column 2 now. So we give this some space to show that we are dealing with a different term. So it's going to be 2 times 3 plus 4 times 2. So it's going to be 4 multiplied by 2. Clear? So the first term, which is 2, multiply the first term in column 2, which is 3. The second term in row 1, multiply the second term in column 2. Alright? Now we are finished with row 1. So now we are going to use row 2 to multiply column 1. So it's going to be negative 1 times 1 plus, go to the second term, it's going to be 5 times 6. So it's going to be 5 times 6. Then we are going to use row 2 to multiply column 2 now. So it's going to be negative 1 times 3 plus, it's going to be 5 times 2. So it's going to be 5 times 2. Now, at this stage, if you want to ensure that you are on the correct terms, or you are on the right track, whatever digit is here, that's supposed to be the same digit here. So here I have 1, also have 1. Here I have 6, I also have 6 here. Here I have 3, I also have 3 here. Here I have 2, I also have 2 here. Alright, so that's just a little pointer. So now 2 times 1, that's going to give us 2. So we are going to have 2 plus 4 times 6, that's going to give us 24. So it's going to be 24. Here, let's do this one. Negative 1 times 1, that's going to be negative 1 plus 5 multiplied by 6, that's going to give us 30. Then we move to this term here. 2 times 3, that's going to give us 6 plus 4 times 2, that's going to give us 8. Negative 1 times 3, that's going to give us negative 3 plus 5 times 2, that's going to give us 10. Now we only have one final step to go. Now 24 plus 2, that's going to give us 26. 8 plus 6, that's going to give us 14. Negative 1 plus 30, that's going to give us positive 29. Negative 3 plus 10, that's going to give us positive 7. So our answer here, AB is going to therefore equal to 26, 14, 29, 7. And note here that our resulting matrix is actually a 2 by 2 matrix. Alright? 2 rows and 2 columns. So that's how you multiply matrix. Let's look at some other example. Here we are given matrix P is equal to 3, 1, negative 2, 5. Matrix Q is equal to 3, negative 4, 1, 0. And matrix R is equal to negative 5, 3, negative 8, 1. So all matrices are 2 by 2 matrix, which means that they can be multiplied because the number of columns in the first matrix is equal to the number of rows in the second matrix. So we're going to find PQ, right? So if we're going to find PQ, it's going to be row times column, right? So it's going to be row times column, and remember that we multiply corresponding elements or term. So it's going to be 3 times this 3. So we're going to write it here. So it's going to be 3 times 3 plus, it's going to be 1 times 1. So it's going to be 1 times 1. Then we use row 1 to now multiply the terms in column 2. So it's going to be 3 times negative 4 plus 1 times 0. So it's going to be 1 times 0. Now we are finished with row 1. Now we are going to go to row 2, and we're going to use row 2 to multiply the terms in column 1. So it's going to be negative 2 times 3 plus 5 times 1. Similar. So it's going to be negative 2 times this 3, then 5 times 1. Then we're going to use row 2 to multiply column 2. So now it's going to be negative 2 times negative 4. It's going to be negative 2 times negative 4 plus 5 times 0. So the next step, we're going to have 3 times 3, that's going to give us 9, plus 1 times 1, that's going to give us 1. Then negative 2 times 3, that's going to give us negative 6, plus 5 times 1, that's going to give us 5. Now we're going to multiply 3 times negative 4, which is going to give us negative 12, plus 1 times 0, that's going to give us 0. Negative 2 times negative 4, that's going to give us a positive 8. Plus 5 times 0, that's a 0. Therefore, matrix PQ is going to equal to final answer of 9 plus 1, that's going to give us 10. Negative 6 plus 5, that's going to give us negative 1. Negative 12 plus 0, that's going to give us negative 12. And 8 plus 0, that's going to give us 8. So therefore, PQ is going to equal to 10, negative 12, negative 1, 8. Alright? So now we're asked to find QR, which means that, note that Q is a 2 by 2 matrix and R is also a 2 by 2 matrix. We also note that the number of columns in Q is equal to the number of rows in R. That means they can be multiplied, and we know that our resulting matrix is going to be 2 by 2. So here again it's going to be row times column, right? So it's going to be 3 times negative 5, so it's going to be 3 times negative 5 plus negative 4 times negative 8, so it's going to be negative 4 times negative 8. Then it's going to be row 1 times column 2 now. It's going to be 3 times 3, so it's going to be 3 times 3 plus negative 4 here times this one. So it's going to be negative 4 times 1. Then we are finished with row 1. So now we are going on to row 2. We're going to use row 2 to multiply column 1. So it's going to be 1 times negative 5. So it's going to be 1 times negative 5 plus, it's going to be 0 times negative 8. So it's going to be 0 times negative 8. Then we're going to use row 2. So we're going to use row 2 to multiply column 2 now. So it's going to be 1 times 3 plus 0 times 1. 0 times 1. Our next step is going to do the multiplications. So 3 times negative 5, that's going to give us a negative 15 plus negative 4 times negative 8, that's going to give us a positive 32. Then 3 times 3, that's going to give us 9. Now, negative 4 times 1, that's going to give us negative 4. So we're just going to write minus 4 here. 1 times negative 5, that's going to give us negative 5. And 0 times negative 8, that's just going to give us 0, so it's going to be plus 0. 1 times 3, that's going to give us 3. And 0 times 1, that's going to give us 0, so that's going to give us plus 0 here. Now to our final step. Negative 15 plus 32, that's going to give us a positive 17. Remember that negative 15 plus 32 is just the same thing as saying 32 minus 15. Then here we have 9 minus 4, that's going to give us 5. Negative 5 plus 0, that's going to leave us with negative 5. And 3 plus 0, that's going to leave us with 3. Therefore, QR, matrix QR is going to equal to 17, 5, negative 5, 3. And that is how you multiply matrix. Thank you for watching, and I hope that you would have found this video interesting. Please remember to like, share, subscribe if you are new. Thank you.